Welcome back, viewers, as we continue on KCL. So, in the last topic, we talked about the introduction to KCLs and the hints and tricks on how to approach questions on KCL. So, we stopped at a procedure to solve a complicated problem in KCL. So that is where we are going to continue from now. So we are going to look at some questions before we move to the next necessary topic. So what we have here, we have the procedure to solve a complicated problem in KCL. So that is where we stopped in our last class. So we are going to take some questions on that and solve it so that we can move ahead. So we've said that start from the unknown value in the problem and find the right equation that can solve this unknown. So the equation we are talking about is still talking about the KCL equations we talk about that we gave um, some methods. We have the first method which says the algebraic sum of current in a circuit equal to 0, while the other one is the sum of current, the algebraic sum of current that enters into a node, and the one is equal to the algebraic sum of current that leaves the node. So we are going to apply them in solving them. So that is with the equation we are talking about here. That's when we talk about right equation. The next step, we determine the new unknown of the equation in step 1 and find the equation to solve this unknown. So repeat step 1 and 2 until there are no more unknowns in the equation. That is how we're going to continue to do it over and over again until we get our final answer. So that is what we're going to apply in this question here. So in the question we have here, we have a very big um, schematics here. So we have in this schematics we have some nodes. We have node A, B, C, and we also have another node here. So we are going to solve them, but the question originally was to find I1. So that's where the question comes from. We have to find I1. So where do we start? Which means our I1 is our first unknown that we should take note of in this question. So now, what is the position of I1? Oh, excuse me. So this is the position of I1. So the I1 is the current that enters into the schematic from the beginning. That's where we have I1. So we are looking for the current I1. So it is unknown. So inside this schematics now we have 4 ampere. You can see it's going to this direction. Is entering the node. So where can we find I1? We can find I1 at the node what C. So if you look at this line, I2 is leaving. This is an I2. Excuse me if it is not clear. This is I2. I2 is leaving the node, and this one also we have 3 ampere is also leaving the node. So we are going to start by saying applying. So in our last topic, we used the first method of the first approach, which is the sum of algebraic current in a circuit is equal to 0. But we are going to use the KCL second method now. So which is by applying KCL, the second method. So we see that the algebraic sum of current I in that enters into a node, it will be equal to the algebraic of sum of current that leaves the node, which we call I out. So I hope that is well taken. So now we can proceed. So we are looking for high I1, which makes that one our first unknown. So we are going to say, and our I1 can be found at node C. So that's where we are starting from, at node C. Node C. So what do we have? We have I1. So which is we are going to take the current. Let's not forget uh, our formula that we are using, our equation we are using. So that's why we said we should look for right equation. So this is the right equation we are picking now. So we are looking for what the current that enters. So if you look at it, this current enters the node while these two are leaving the node. So we are going to at C. What happens at C? I1 enters the node. So and plus what? Plus 4 ampere. So on the other hand, we have what? Equal to the what? Sum of the current that leaves. So the sum of the current that leaves is what? We have I2 plus 3 ampere. So 3 ampere. So the problem now again here is what? What is I2? So I2 is unknown again. So if I2 is unknown again, we are still going to recall back to our procedure. We said determine the new unknown, so which is our I2. We have determined the new unknown in this case now. So of the equation in the step 1 and find the equation to solve this unknown. So we are going to repeat the step 1 again so that step 1 so that we can continue. So the new unknown we have here is I2. So we have to repeat the step we just used. So which means um, beside I1, another unknown is what? I2. So we have to what? Look for the rightful equations as well to solve for I2 as well. So where can we find our I2? If we look at our I2 is entering another node what? Another node B. So that is where we are going to take it from in this case. So we are going to continue again. So um, okay, this is node A. So let's just start and steady with this one so that we will not get confused. So let's look at the second one, which is at node B. At node B, what happens at node B? So if you look at node B, all these conventional current are also what? Involved, while those ones here also are involved. So if you look at what happened at node B, so we are going to what? Say what? Applying what? Applying the same KCL2, which is what we have been using from beginning, so that to make it easier for us, which is I in sum of I in equal to sum of I out. So what are the current that is entry node B? We only have what? I2 is entering node B. So not only that, we also have what? 3 ampere plus 3 ampere are entering node B. So which one is leaving? So the other one, what are the ones that are leaving? We have 4 ampere is leaving, plus I3 is also leaving. So since they are all coming with we don't have issues here. So all of these two are coming from B. So they are going to be are going to take them as part of the current that are leaving node B. So the same thing, I2 is coming from that direction at 2 ampere, sorry, is coming from that direction as well. Definitely it's actually leaving the node. Excuse me. So you have what? Plus 2 ampere. So that is what we have here. So by the time we add these ones together now, we're going to have um, I2 plus 3 ampere equals to, so by the time we have this over this, we have I3 plus 6 ampere. So I hope that is where we can stop on it. So because in this equation now there is another unknown that we have here. So another unknown value has been introduced here, so which is I3. So our problem again here now is going to be what? I3, which is our new unknown. So if that's our new unknown, so let's continue from this side. I don't want to jump to another page so that we have the same thing, everything on the same page. So now which means apart from I2, we also have our what? Another unknown, our I3 as another unknown. So what do? We continue with our equations here. So we continue to repeat the method, one after the other, until we finally find the solution to what we are looking for. So now the next thing we are moving to now, we are going further to another node here, which is node A. So I think probably node A should be able to produce answer to what we are looking for, so that we can get what we are finding from the beginning. So let's continue from here. At so Next one is at node A. So what happened at node A? So if you look at node A, we have what? I3 is entering node A. I'm very sure we are all following. So if you look at node A, we have what? I3 is entering node A. So we are still making use of the same method. That is what it means. So I3 is entering and 4 ampere is also entering. So while uh, 1 ampere and 5 ampere are leaving. So which means, so if we are considering I in first, we have what? I3 I3 plus 4 ampere. So I think we are done with that. So what is again? The one that are leaving equal to the sum of one that are leaving. So we are going to have what? 5 5 ampere um, plus 1 ampere. So which we can say I3 plus 4 ampere equal to all this together going to be 6 ampere. So now if we take this to the other side, we're going to have our I3 is equal to 6 ampere minus 4 ampere. So our I3 is going to be 2 ampere. So that is the uh, value of I3, and that will give us the idea of what we are looking for in our equation. So now with our I3 to be known now, so we can now further ahead and discover the remaining parts. So how do we do this? So it's very simple. We can go back to, let's say, I should have termed all our equations. So let's say at this point we have equation 1, at this point we have equation 2. Let's say we have equation 2 at this point. So this is our equation 3, at this point. So now we are going to do what? We are going to substitute I3, the value of I3, into equation um, equation 2. So that is what we are going to do. So if you recall our equation 2, we notice we have what? We have I2 plus 3 ampere is equal to I3 plus 6 ampere. So by the time we replace I3 with the value we got here, we are going to have a I2 plus 3 ampere equal to 2 plus 6, so ampere. So our I2 plus 3 ampere is equal to, all this together is going to be 8 ampere. So our I2, if you take this to the other side, is going to be, I2 is going to be 8 minus 3 ampere. So our I2 is going to be 5 ampere. I hope that is well taken. So now that is the value of our I2. So now we can now find our I1, that is what we are looking for from the original question. So now by substitution, so let's just say substitute I2 and I3 into equation 1. So what does equation 1 gives us? So please don't let us mix it together. So that is what we have. What does equation 1 gives us? So equation 1 gives us to be, if you recall it, so we have our equation 1 to be I1 plus 4 ampere equals I2 plus 3 ampere. So okay, I'm very sorry, we don't even need I3, so we should just erase that one out. So we don't need that, we should just erase that one out. So I'm sorry. So now what we just need is our I2. So after we have gotten our I2 to be 5 ampere, we just plug it into this place. So we are going to have our I1 plus 4 ampere equals to 5 plus 3 ampere. So what do we have here from here now? We're going to have our I2 is equal to 4 ampere. So sorry, it's going to be negative 4 ampere because we have transferred it already automatically. So, and this one is going to be positive 8 ampere. So by the time we negative 8 4 plus 8 ampere, our I will give us the value of our I1. So this is I1 and this is I1 as well. This is I1. So this I1. Our I1 is going to give us 4 ampere. So that's the value of our answer, 4 ampere. I hope that is well taken. We can go through it over and over again from the top. So since we are done with this now, I believe we can apply the same method based on the procedure we have given from the beginning to solve a complicated problem under KCL. So we can apply this to any question under KCL based on this topic that we just treated. You are free to share any questions on our email that will be provided on the screen at the end of this video. So now, away from this, now we're going to move to the next topic on our agenda list, which is what we call a supernode. The concept of a supernode can be extended to a circuit that contains several nodes and branches. So, like what we have here. So, and the circuit can be treated as a supernode. That is why we call them a supernode. So, like the one we have here. So, we have a circuit um, between nodes A and B in this schematic. So within this the dash circle, so we can treat this as an extended node or a supernode. So which means as well that KCL can be applied to it. So what does it mean? It means that the sum of currents from this side that enter into this junction, no matter what is going to take, no matter where any area that it follows, is going to be also the same will be the same to the amount of current that leaves the circuit on the other hand. That is what it actually means. So we can verify this even with the question we just finished under KCL. So if you look at this from the question we just finished under KCL, we will say that by the time we calculated this I1, we found that our final answer gives us what? 4 ampere. So now, which means I1 is the 4 ampere enters this whole schematics, this whole circuit. Now what is IB? So which means they come out and those things, and the current that enters there leave this place. So what are the two currents? Look at the two currents, which is 3 I3 and 2 ampere here. They are the ones that came out from this point IB. So IC, so IC is the node that enters this circuit, while B is the node that that leads to the exit of this circuit. So we only have two current that leaves. We have I3 and 2 ampere. So and our I3, by the time we calculated it, we got our I3 to be 2 ampere. So if we add 2 ampere, the value of I3 to this one, it will give you 4, which means it's equivalent to the I1 that enters the circuit from the beginning. So which means it's the verification of it, but of course we are still going to cover it under the supernode as well, so for better understanding. So that is the application of KCL in this case. So let's quickly let's take a look at this question before we round up on that supernode. So to verify what we have been talking about. So this is an example of supernode from A, B, C, and D. So and this one is under another circle, a dash circle here, and I'm going to show. So please don't mind my drawings and my handwriting. I might be bad sometimes. So in drawing, so and now look at the schematics. We are being given our I1. This is I1, the current that enters um into the first node, and our the current that lives in the node from the other end is I7. So we are given I5. So now we are going to use our KCL to verify if we are going to have the same I5 on the other end. So that is what the supernode is all about. So which means and a KCL can also be applied in a supernode, or we call it an extended nodes circuit. So that is what we are looking at here. So we have our I2 to be 6 ampere, our I3 ungiven, we don't know the value. I4 is not given, I5 is 4 ampere, I6 is 1 ampere, and our I7 is unknown that we are looking for. So we are expecting what? We are expecting 5 ampere at the other end of this question. So that is what we are going to look at now together. So we are going to start from the beginning. So we already know the law we are applying is what is a KCL. So we are making use of the uh, first method, which says what the sum of the current that enters into a node is equal to the current that leaves the node, which is I sorry, which is I summation I in it must be equal to I out. So that's what we are looking at. So and we are to treat what and we are to treat the circuit between A to D inside this that circle as a what a super node, and the current entry in it is or A, while the should be which should be also equal to the current that is leave, which is D. So what are we looking at? We are looking at our I7 to be equal to um I1 I1, so which is the same thing as what? 5 ampere. So that is what we are looking uh, at the end of this solution, at the end of this question. So now we are going to start what? At the beginning, which is what? Let's quickly take away this one. Uh, so we are going to say by applying KCL to, so which says that um okay, I think we have already taken it as but I can't place here too, which is what we have here. I in equal to I out. So now we are starting from the first uh, node here, which is at the top. So we are going to have what we are going to have at node A, which is what we have here. So the sum of current that is entering the node is what is I in. We have I in must be equal to I out. So if you look at this, what does it mean? So our I in is actually what? 5 ampere, which is the value of our I1. So let's start with our notation first. So this is I1, so this is I2 on the other side here. So now the unknown we're having here is what is our I3. So if you look at our I3, how do we know? Does it enters or it leaves? So if you look at for KCL to be obeyed, if you look at this one, it's leaving already, so which is 6 ampere. So this one is entry, which is 5 ampere. So we need this one to enter so that it can equivalent to the one that enters, so which is also to be equal to the one that leaves. So definitely our I3 is entering. So our I3 will be on the side of what I in, which is plus I3. I hope that is well taken. So what I said it was that for KCL to be obeyed according to what we gave here, so we have our height to be leaving the leaving the node, so which is equal to 6 ampere, and the one that is entering is what? It's 5 ampere. So we have to determine where this one, the direction. So that is what we're looking at, the magnitude and direction, so which of Y3. So we have to determine the magnitude and direction of I3. So if I3 is supposed to be leaving, so definitely KCL is not obeying the rules. So which means we are going to have the number of current that is leaving more than the one that is entering, which is not the basic rules of KCL. So now if it is entering, definitely is going to obey the rules, and what is going to enter is going to be 1, because 1 point plus 5 is going to be 6, which is equal to the one that is leaving the node. So that is why we have our I3 on the side of what? Of I in. So I2 is the one that is outside. So our I1 is what? Is 5 ampere plus I3, which is equal to 6 ampere. So by the time we do this, our I3 will definitely give us will definitely give us will definitely give us, if we transfer this one, 1 ampere, sorry, 1 ampere. So if we transfer it, that's what we are going to have. Now we are not done to that with that. So the next thing we are done, we are moved to the next node. So the next node we are going to move now to, let's move to node B at node node B. So what happens at node B? So let's quickly demarcate that. So what happened at node B? If you look at node B, so I in, what are the things that entered node B? We have our I2 enters node B. So what else again? So we have I4 here too. We don't know, maybe I4 enters or leaves node B. So let's just give a space here. So we have our I5 is leaving node B. So if you look at it, our I5 is leaving node B. So we are having I5 on the I out is leaving node B. So now, so what is going to be the fate of I4? So that's going to be what we are going to be concerned about. So since our the current that is entering is what, the value of I2 is 6, and this one is already what, 5. So we have to make sure that the word KCL is obeyed. If KCL is supposed to be obeyed, so then it should be obeyed. So the sum of the current that is entering the node must be equal to the sum of current that is leaving the node. So we have 6 that is entering the node. Definitely 6 should be leaving the node. So which means I4 is leaving the node. So that will be the direction of I4. So I4 will be supporting, will be on the side of what, of I5. So I4 will be also what, leaving the node. So what we are going to have here alone is going to be our I1. So our I1 is I2, sorry, and our I2 is going to be 6 ampere. So which is equal to what, I5, which is our I5 is what, 4 ampere plus what, I4. So by the time we do this now, we are going to transfer this onto this side. So our I, sorry, okay, yes, correct. Our I4 is going to be 6 minus 4. So which is going to be 2 ampere. So that will be the value of our I4. So which means uh, 2 ampere is living on the I4, and 4 ampere is living on the I5. Everything will be 6 leaving node B, and 6 is also entry node B. Definitely the law KCL is obeyed. So the next thing we're going to look at, let's move to node C. At what happens at node C? At node C, what do we have at node C? Let's quickly demarcate that. So at node C, we notice that what, so we already know, okay, we have already find out that the direction of our I4 is leaving node B. If we are not, yes, it's leaving. So our I4 will be in this form. So on our I3, if we are not mistaken, I think we have done that too. So our I3 is entering node A. Definitely is leaving uh yeah, it's definitely is leaving node C. So that is, I think that is very easy to discover. So our high at node C now is going to be only I4. So only I4 is entering node C. So only I4. So, and we on the other side we are having what, I6 plus I3 that is leaving. So our I4 is going to be what? What's the value of our I4? So I think our I4 is oops, our I4 is 2 equals to uh, I6. Okay, everything has been given. We have 1 ampere here, and we have a what again? We have a 3, what do you call it? Our I3 to be what? We are going to have it to be 1 ampere as well. So definitely at node C we have no unknown value. So they are known already. So we shouldn't have even taken that. So the next thing we are going to look at is node D. So node D is our major concern now. What happened at node D? But it's good at the way we take this so that we follow every rule, so that we cover the whole circuit. So what happens at node D? So at node D, so uh, at node D, So we look at node D. So the sum of current that enters, we don't need to bother ourselves. So there's no more of stress here. We have current that enter is what? Is I5 enters, and what? And I6 also enter, plus I6 also enters. So if you look at everything together, it's going to be the sum of current that leaves, which is I7. I7. So now, what is the value of I5? Our I5 is what? Is 1. Sorry, is 1. And our sorry, excuse me. So our I7 is going to be I5 I5 plus I6. So I'm missing everything up. I'm sorry for that. So our I7, which is the value of what we're looking for, uh, is going to be, the value of our I5 is 4. I'm sorry for that. So that is 4 plus our I6 is 1, is 1. So which is up to 5 ampere together. So our I7 is going to 5 ampere. So which means the whole thing is well taken care of, and the law KCL is applicable and obeyed in a supernode. So which means the sum of the current that enters an extended node or supernode is also the sum of current that leaves. So that is what we got. So that means this what we are expecting here is what is correct. Is correct. So we can go through it one after the other. So that is on that note, we are going to stop here on this topic. More questions on